Okay, let's begin. Saudi Carnot was thinking about the motive power of steam in the 1820s, and about 100 years prior to that was the first practical steam engine that was invented by an Englishman named Thomas Newcomen in 1712. The Newcomen engine was used in the mining industry to pump water out of mines. In 1712, Britain was laying the groundwork for what would become the Industrial Revolution. And one of the technologies that was necessary to have an Industrial Revolution was mining, particularly in the western part of England, in Cornwall, where for centuries people had been mining tin and copper and other metals. But whether you're going to dig a hole in the ground for iron ore or for coal or for some other metal, sooner or later that hole is going to fill up with water. And that's where the Newcomen engine comes in. The Newcomen engine had the advantage of being very simple and very reliable. So let's see how it worked. The Newcomen engine consisted of a cylinder. And in the cylinder was a piston that would move up and down. So the way it worked was we fill the cylinder with steam, and the steam causes the piston to rise. The pump is attached to this part of this overhead beam. So now we inject water, cold water, into this cylinder. The cold water causes the steam to condense. When we condense the steam, we create a vacuum, and the atmospheric pressure pushes the piston down, resulting in the power stroke. Fill it with steam, inject cold water, atmospheric pressure pulls the piston down. Now, there are a couple of serious problems with the Newcomen engine. The first serious problem is, of course, that the power stroke relies on a vacuum. And the atmospheric pressure is 14 pounds per square inch if you use the English system, as Newcomen did. So the pressure of the power stroke cannot be greater than 14 pounds per square inch. So the only way to get more power out of the cylinder or more power out of the piston was to make the piston bigger. The other serious problem with the Newcomen engine was that we are causing it to go through hot and cold cycles. We heat up the cylinder when we allow steam to go into it and cause the piston to rise, and the cylinder cools down when we condense the steam with cold water. The metal gets hot, the metal gets cold, the metal gets hot, the metal gets cold. And every time we have to heat and cool that metal, the engine is wasting fuel because we're spending a lot of the energy heating up the metal every time we do a single stroke of the engine. Now, at this point, the next major improvement on the Newcomen engine was by the Englishman James Watt. James Watt was an instrument maker, and he was hired by a university to make some repairs to their scale model of a Newcomen engine. And James Watt immediately realized the principal limitation of the Newcomen engine, and that is the heating and the cooling of the cylinder every time we do a power stroke. The constantly heating and the cooling of the cylinder was wasting so much energy. So what James Watt figured out how to do, which way is it reading correctly? Ah, yes. He attached a separate condenser to the Newcomen engine. Okay, so we let steam in, and we cause the piston to rise. Now, instead of injecting cold water to condense the steam, we allow the steam to travel into a separate condenser where it is cooled. Now, because this separate condenser is isolated from the cylinder stays hot, but the vacuum still forms. So the cylinder stays hot, we still get a vacuum, and that vastly improves the fuel efficiency of the Newcomen engine. James Watt is going to make a number of other improvements to the steam engine in the next few years. So let's go to our next video and talk about that.